Welcome to What, Why, How Engineering. In today's video, we'll break down and go through two example questions covering atomic structures, lattice parameters, and ionic solids, which is the work that we looked at in the previous video. If you haven't watched the previous video, kindly have a look at it before proceeding with this video, as it covers the theoretical concepts that we will be using in this video. Check out the link for the previous video in the description. Let's have a look at our first example, whereby we are asked to solve the three sub-questions in relation to the figures shown. In part A, we are asked to determine the relationship between the atomic radius r and the lattice parameter, A, and in order to do that, we start off by drawing a cross-sectional view of the unit cell, which is a BCC unit cell in this case, as discussed in our previous video. If we are to consider the close packing of the atoms in the unit cell, the cross-sectional representation of this unit cell can be reduced to the following as shown in the sketch. Using Pythagoras' theorem, we can find the relationship between the atomic radius and the lattice parameter, giving us the relationship of A and R. Let us now look at part B of this question, where we are asked to find the atomic packaging factor for the BCC unit cell structure shown in the figure. To calculate the atomic packaging factor, we have to calculate the volume of the atoms in unit cells, as well as the total volume of the unit cell. For BCC, the number of atoms per unit cell equals 2, and the volume of one atom. The total atomic volume and the unit cell volume can be calculated as follows. We can then substitute these values and expressions in the APF formula and solve. Now, let's look at the last question where we are asked to find the planar density of the structure. To find the planar density, we have to calculate it using the following formula, which we showed in the previous video when we were discussing the principles of crystal structures. The number of atoms centered on the plane is calculated as follows, whereby each corner atom has a contribution of a quarter, thus the total number of atoms can then be calculated. Then, the area of the plane is calculated as the area of the unit cell square figure. Taking both of the calculations will then enable us to calculate the resultant planar density. In this example, we are given some information about gallium, which has an orthorhombic crystal structure, and we're asked to determine its atomic packaging factor. We know that the formula for calculating APF is given as follows, and thus this means that for us to calculate APF, we have to first calculate the inputs to this formula, which are namely the volume of the unit cell as well as the volume of the atoms. Starting with the volume of the unit cell, we get that the volume of the unit cell is 0.157. Secondly, we now have to calculate the volume of the atoms in the structure, but we realize that we do not know the number of atoms that are in the structure, and thus we have to first of all determine the effective number of atoms. The effective number of atoms can be calculated using the theoretical density formula as follows, whereby the effective number of atoms is found to be equal to 8. Then, having found the effective number of atoms, we can then calculate the volume of atoms, and then along with the volume of the unit cell, we calculate the APF, which gives a value of 0.387. Thank you for watching this video. If you loved this video, please leave a like and subscribe to the channel. See you in the next video.